Hi, it's time for another math easy solution. Today we're going to discuss further into parametric curves and now look at example 4 of the example series and solve this example, which states sketch the curve with the following parametric equations, and this time we have x equals to sine t and y equals to sine squared t. So if we solve this, well, first thing to do is, well, note that y, since x equals to sine, then what we have is, well, y is simply equal to x squared, because x is equal to sine t, and there you have sine squared. Yeah, now this equation y equals x squared is simply a parabola. But the difference in this case now, since we're defining it by these parametric equations, we have to see what the domain is of this t variable and this x and y domain and range. For example, here I'm going to write as, but note also that what we have is this sine of t, so x equals to sine of t, and where, again, sine is just a trigonometric function where it is periodic going with its highest value of 1 to its lowest value of -1. So this is less than equal to 1, but greater than equal to -1. So x is between -1 and 1. And also what we have is, and for the y function, so we have y equals to sine, this is going to be sine squared of t. So, which is the same thing as equaling to x squared. So then the highest value here is 1, but then when we square it, well, we still have 1. Lowest value is -1. When you square it, it's still +1. But sine, remember, it goes from -1 to 0, so -1 to 1, but it crosses 0. So this is greater than or equal to 0. Yeah, so y is lowest value is 0, highest value is 1. For x, it's -1 and 1. And also when we graph this, what we end up having is, again, it's a parabola. So this is x, this is y. We know what the parabola is, where when you have x equals 0, y is equal to 0. So you start off here, where that's at the x0 mark, and it goes something like this. I'll draw this across like that. So it's a parabola like this, and it just stops here, it doesn't keep going. At this point right here, this is at x is equal to 1. This is x equals to 1 right here. And then at this point across here, when you put in x equals to 1, y is also equal to 1, and also y, the highest value is 1 there. So at this point is 1. So let's draw this a bit higher up, like that. So that's 1. So at this point we have 1, 1. And then likewise on the left side, it's all the way to -1. Draw this a bit closer to this. So this is -1, and then at this point is going to be the same thing as before. So -1 and now 1. So it's a parabola that goes like this, from -1 to 1 right here. Yeah, but like I've gone over in my earlier videos, the parametric equations don't just define a curve, but it defines how the curve is traced by assuming there's a particle that moves across it. So in this case, but since sine of t is periodic, then the point x, y, in other words, sine of t, sine squared of t, let's put a random value like this. This is going to be, let's say, x, y. Moves back and forth in infinitely amount of times along the parabola from -1 to 1, -1, 1 to the point 1, 1, and vice versa. That's because, again, this sine of t, as you increase this, or whatever value this is, sine is going to be between -1 and 1, and recall that trigonometric function, in this case sine, just goes up and down. So what that means is we're going to be fluctuating. So we're going to go from here, we're just going to move the values across with time. I'll just erase this like that, and then it's going to go back and forth, and then going this way. So basically, as you change your values of t from -infinity to +infinity, it's just going to go up and down, back and forth, infinitely amount of times across this parabola shape. So yeah, that's all for today. I just wanted to show this quick example on how parametric equations can be used to graph such simple curves like a parabola, but behind the scenes, the particle, this one, in this case right here, this right here is our x, y, and this one is just moving back and forth as you're changing the t value because of the periodic nature of the sine function. Anyways, that's all for today. If you learned and enjoyed, and like always, you can download these exact notes in the link below. And thanks for watching, and stay tuned for another Math Easy solution.